Hello and welcome back to a new video in the series of Lunch and Learn. In this video, we'll look at some thoughts of how to set up an engineering team for an EPC project. In the beginning, I would like to say that I have the pleasure to be working with a very fine teams. Teams starting maybe 4 or 5 guys, and teams I was leading a team of 35 or 40. And I also have the privilege to be leading a team of in EPC companies for up maybe 60 guys, and then I'm a deputy for more than 110 designer and engineer. The success of any of these projects was actually because of the success of the people actually who did the major job, and they make the success of the project. So as much as a team together put effort in the project, as much as the project succeed and reach a good position. So let's back to the video. Who may be interested in this subject? Any overall lead, silo lead, project engineer, or anyone who is working in any engineering, and sometimes also the ideas we were talking about here maybe serve somebody else, even if it's not engineering field. So if we look at an EPC project, you have team, could be 5, could be 50, could be 100. So the more people you have in the team, the more need for a way to arrange the team. Regardless of this project is reimbursable or lump sum, it's still you have a lot of pressure to organize a team. Definitely if you have 5 guys, you expect that the lead will be 70%, maybe 60, 70 to 80% involved in the technical stuff, and only maybe 30% to 20% in managing the team. However, the more people you have on the team, the more time you need to dedicate for the project management and make sure that the progress and the development of the deliverables are working perfectly and there is no issues. Now, the more you have team, again, the more time you have to look at organizing the people more than going into the technical. Still, you need to look at the technical, but you maybe not have enough time to work any by yourself to produce any deliverables. But the problem now, when the team grow more and more, then you can find that your roles has to change. Your roles has to go a little bit different, because now you consume the time sheets, make sure that everybody is available. Some people will leave the project. You have to hire new guys, performance of some people. So it's kind of time consuming and will take you a little bit far away from the work floor. And but you should not ever leave the team without touching the day-to-day business, like to know what's going on. So you have to be somehow knowing what is going on, at the same time not involved in everything. Otherwise you will not have time to do the job you're supposed to do. So one of the issues, if many teams, people you have, what does it mean? You need a lot of man hours. So in the beginning of the project, you or maybe someone else had estimated that you need 1,000 hours to do the job. The hours which is estimated goes through maybe the discipline manager. The discipline manager will chop a little bit and say, no, you need 800. Then it goes to the business development, who knows that we are competing in a very tough situation. Now we can't get the job with this number of hours. We have to chop again, and it's end up by 600 hours, which is you have actually to work and live with it and produce within the 600 hours. So you have to think a lot, not putting a lot in this in the first place, but how to manage the deliverables in the team with a less hours. So let's see what you have. You have man hours estimated or already had been ordered to you. You have to deliver some deliverables, and do some activities in a specific time, which is a schedule. So let's see, this is an INC, a typical INC deliverables. If you are in mechanical or civil or any other discipline, you will have a different set of deliverables. Activities really can be summarized in 3 categories. The first one is the stuff which is your team will develop, sign, stamp by themselves. Some stuff they will input, like the INC guys, we have inputs in PNID, but the owner of the PNID is the process group. Single line diagram, isometric for the mechanical guys. So they will have only to review, put their comments, give it back to the owner. Some other activities you need to do with the site surveys, evaluation studies, the HAZOP and hazard and others. So this is a typical type of activities. So let's go back again and look at how the man hours is estimated to understand how many people you need to do it. So if you look at any deliverables, like a wiring drawing, you need to look at what's the effort, what's the steps needed to develop this drawing. So in this case, like the wiring, you have many things. One of them is data entry, which is have nothing to do with the wiring, but something called a database tags input. So that will be calculated by itself because it serves the wiring, it serves another stuff. So it's one common item, which is, let's say you take some hours or minutes or whatever per tag. Then the other drawing here is a loop drawing. You know that each one will take 8 hours, and then multiply 8 by 300, you got the total hours. You know that this 8 hour includes someone is developing it, passing to a CAD guy to CAD it, and then come back to him, review it, send it back to the CAD, send it to the peer review, send it to internal reviews, send it to client review, then final issue. So this is another one method of calculating how many hours you need for a drawing, a typical drawing. Now, there is another activities which is you cannot do it this way. Same as an example. Let's say document control, database administration. You will say, I will need 4 guys for 5 months. Then I need 2 guys for 3 months. Then I need 1 guy working at 60% of the hours for 2 months. And this is how you get up how many hours for, let's say, for the database administration. Some of the drawing, when we talk about, they will be reviewed by this guy, this guy, this guy. So each time it goes out of the door, it goes through document control, it goes through process of signing, checking, and so on, and printing. So that's time consuming. I have seen project, I worked in project, which they use a different methodology. They use design progress. When you reach 30% design, you have to develop drawing 1, 2, 3. When you reach 60%, you have to issue drawing 1, 2, 3, and 4, 5, and so on. So this is another method. So again, each one of the drawing you have to state each required milestone for this drawing, and then this milestone has a date. Definitely you will have some people who are working on the schedule, as we will see in a slide coming now. But now we understand you have a scope. This scope, you have to do it with some man hours and within some schedule. Of course, you have to think about quality, scope, and a schedule. You cannot sacrifice any one of them in favor of another thing. So you cannot, let's say, oh, I need to maintain my schedule, I have to cut the scope, or the quality of checking will be reduced. This is not in question at all. So this is out of thinking immediately. Okay, so now, what may help us in achieving this, or optimizing the hours, or optimizing the work when we are doing? One of the things which is in the beginning, before you do anything, you have to look at your PNID, you have to look at your scope, a scope of work, and all those documents. And look for something which is maybe repeated, plant, silo, trains, and you look at the deliverables, what you're supposed to be producing. Let's say cause and effect. I'm talking about INC again. Isometric for mechanical. How many isometric? It's 3,000, it's 300, and so on. And what resources you have, right? So also you have to look at what resources the company is providing for you. So this is points for your planning. And then we will look at our scope, put them in a piece of paper, and you know what's your scope. And then this scope, as we said, those drawing, your scheduler in the project will look with you on each one of these drawings, and he will ask you what is a predecessor for each one of those drawings. So this is a deliverables, or a drawing which is have 2 milestones. You started, you ended. You don't need anyone to give you any data. You don't give anyone any data. This deliverable starts from here, and then you give it to someone to work on it. Then in the middle of the stuff, he will give you some input so you can start your deliverables again. This is, you have to wait until they finish a certain thing, and then you start working. So the schedule is kind of tell you what is the stuff which is you can produce, whom you are depending on to start your work, or even to continue working. If you look at the man-hour loading of the people loading, you will find, let's say, the bell curve here. Reality is not a bell curve. You hire 3 people, add another 3, add another 3, and another 2. Then you continue, and then when it's finished, you release a lot of people, and in 2 steps, and then maybe 1 or 2 guys will continue just for the site support. So this is the reality, which is you have to live with it. And also this is how you plan to produce your deliverables. So the first thing in the team formation, you have to look at what you have in the house, what you have outside. You will come up with some problems, you will face some problems. Some of the projects, what they will do, they will ask you to rely on low-cost centers, which is maybe in South America, in another places, South in Africa, in Asia, in Europe, whatever it is, but it is cost less money for the project. And sometimes even they will tell you, our guys in city X or company X city, they don't have any job now, and instead of hiring new people in our company here in this place, we'll use them. So we'll split the work between you and them. So you will face a lot of this stuff right now with all the economy and things happening. So the first thing in planning, there is 2 ways of do the team or arrange the team. One of them is vertical, one of them is horizontal. So vertical, we use it if you have a lot of scope. So if you have, let's say, 2,000 isometric, maybe you will have one big team will do all the isometric. One big team will do this, say, for the everything, all the cause and effects or the control narrative. And some stuff here we say, okay, if this is something repeated, it's exactly the same, so I will use one team doing it for all of my plant. So the difference here is plant 1, control engineer here doing the cause effect. Plant 2, cause and effect by another group. So group for cause and effect, same group for cause and effect, but this is plant 1, plant 2, because there is a lot of things they can. It's not one team can do it. Here you have 5 cause and effects for each plant. So you have one control engineer doing it for everybody. So in this case, we say for instrument database, again, I'm using instrumentation as an example. Instrumentation database will be done or dealt with a one team. Maybe this team is 2, 3 guys, 4 guys, 5 guys. And then they would look at the PNIDs and they make sure that PNIDs data is in the database, and that's it. Then another group for all areas dealing with the database. Then the wiring, all areas here, and so on. Let's see a different scenario. So in this scenario, you have area 1, 2, and 3. So in 3D modeling, area 1 and 2, I have one group serving area 1 and 2. Then I split one of the deliverables. Let's say, assume this is the location drawing for our planned drawing for the area 1 and 2. So area 1 will have guy, area 2 will have different guy. But if you look at 1 and 2, maybe they are exactly the same, and then this is train 1, train 2. So you have to think about a little bit different. Okay, so but area 3, you will have its own team. That's it, dedicated. Maybe this is a completely different place, a different structure. So like this is a boiler. So the area of boilers, and this is a process. So the boilers will be dealt by, because it's cookie cutters here, copy paste. So you will use one team to do it. Again, area 1 control, area 2 control. It's up to you. Again, let's look at something here. Now, team 1, based on your experience, you will say all my control valves in all areas will be dealt by this team. What this will give you a very consistent product. The second, it's higher efficiency. The reason, now assuming they are reading the specs for the control valves. So let's say you have 20 specification. They need to read it once and apply it for all areas. But if you think that it's been split to 5 teams, the 5 teams will have to read the specs. The 5 teams may give you a different data sheets, different selection based on their experience and so on. So this is the first way of doing it. Each team based on the speciality and experience of the team. The second thing is you will let's put all field instrument in one group, right, for area 1 and so on. So now valves, transmitter, and everything for this team. And again for the second and the third. Here we have control valve, team 1, field transmitter 2. Now the mixed, you can see I have a lot of transmitters, but a few of control valve and SDV, and SRV and so on. So you can mix and match. What is the problem with the first method, the experience? You will have some people actually like to work in a specific thing. They very happy to work in control valve all the time for 20 years, no problem, which is okay. You shouldn't have any problem with that. This is people who like to be specialized, doing one job very good, perfectly good, and forever. Some other people, they don't. They like to work. This time I work in control valve. I need to learn something else. So please, I don't want to work in control valve anymore. So make sure that you understand what is going on, and you have to make the balance between the morale and the productivity and the efficiency of your team. Now, if you look at, this is an overall picture of a team. If you can see here, you have a silo lead, and then this silo lead has a lot of personnel here. But he can, and he should, if he found that you have a lot of activities in this area, he should assign sub-lead. In this case, maybe the sub-lead will be producing with the team, but at the same moment, he is responsible to get the data out from the team. I have this as actually, let's say, in a small team. We have about 5 guys working in 3D modeling, and they were doing the location drawing and location plans and so on. So the 4 guys has one sub-lead. He take care of the schedule, he take care of the progress, and then he reported the silo lead. Sometimes you find a silo lead who would like to go and be involved in tiny stuff for each one of them, which is maybe okay, but to me some people actually will take advantage of this, and they will, in each thing they will come to you and say, oh, let me know, how about we do this, how about that, can I do this, can I do that? So sometimes it is wasting of time. If they can do the job, they should do the job. If they cannot do the job, seek help. Try to educate them, put them on the right path, because the best thing is to get the maximum of each one of your team. Not doing what they're supposed to do, even if you know how to do it, but they're supposed to do it, help them do it and make sure they do it correctly. And the system should be in place to make sure the quality of the system is consistent all over the scope. Silo 1, Silo 2, Silo 3, you can see you can have a specific team working in database, and then you have a specific team working for the control here, and because this area you have PLC, this area is a DCS, so you have a specialized guy for a PLC is doing the panel design, which is completely different than the DCS, and so on. So you have to be flexible, look at what you have, and try to get the maximum of your team. So in conclusion, so you have to look at your team. What do you want to do? You need to improve the efficiency. You need consistency. You need the morale of the people and the performance go up. And then you see one of the issues is the weakness and the potential of problems. You have to spot it before it happens. Even if it is a personal problems or a technical problems, right? Because you will find some people who are perfect, great guys actually. They know everything, but they cannot work with a big team. They are very happy with a small team. So don't force them. I found some guy actually, everybody doesn't want to work with him because he was so aggressive. But I found that this guy was so perfect when he was mentoring young engineer, and he was perfectly happy with that. So look at what you can do with your team and get the maximum, the best of them. They will be happy, and definitely it will impact the performance of the team and the project as a whole. And you have to be very flexible and be ready to change your ideas or thoughts about people or about things if you found that it's not really working. Okay, so this is something I'd like to leave you with, which is a necklace. One of them, you have a very nice ornament in the middle, and one doesn't have anything. Some people, the leads of a team, think that they are this ornament. They should be in the middle, in the focus of everything, right? Some people think that the lead is like the small wire which is holding all those nice pieces together. It is there. Everybody knows it is there. They cannot see it, but it is there. They know that this whole setup cannot be there, cannot be this beauty without he being there holding the teams together. So it's up to you. You think about it and see the best for you, for your success, and for the team. The success of the team is your success. So if you have any ideas, please let me know, and thank you for watching, and see you in a new video. Have a great day.